the final Chapter 2 homeworks or the Chapter 2 closure. So today what you need to turn in is anything that's missing from Chapter 2. Check map. It's up to date. But I have lots of no-name on my board. My land of no-names is over here now. Land of no-names is over here now. What's up? Yeah, we're doing that right now. All right, so our answers right here. We're going to go over number 8 together. But go ahead and check all the other answers. Yes.
For the first one, I did 7 plus 3 plus 5 plus 3 plus 3 plus 2.
I think you broke a rule. Because I think it said you can only work with certain numbers. Oh no, you can do 3 plus 3 plus 3 plus 3. So normally when we talk about multiplication, it's telling us how many of what. So here guys, I'll pull this out and show what specifically Dikshit is talking about. I just got to load up my camera. So Dikshit is asking, instead of what they have in the answer key and what they have shown here, could she do 7, 3, 3, 3, 3, and then 2? Yes, because you could do 3 times 4, like 4 of 3. But how this is written, it says 3 of 4, so we would show out 3 of 4. But if you do 4 3s, that's also fine. That's the same. It's like switching the multiplication order around. Number B, we could get 25, we could get 42, we could get 60. We can play with these numbers. We can get lots of different stuff. Hey, now is when you need to be telling me you need this worksheet.
Yeah, I was about to tell you.
Yeah, but it's Katie's job.
You're right, it is.
Anybody else not here yesterday? You got to do our job. All right, so let's talk about 3-8 together. We're doing it together. So, in 3-8, and yeah, you probably shouldn't highlight your book, but I'm going to highlight mine since these are printed pages and I can always print more. Distance between points. When we talk about distance between numbers, like the distance between 5 and 3, what do we normally do to figure out that distance or like the difference? Subtraction, right? A couple people mumbled it. Sorry for those of you that raised your hand. Yeah, subtraction. So distance between, if this pencil would work, this is telling us we're going to subtract. Now, we don't always have to use absolute value, but sometimes we need to use absolute value. Jesus? Can you what? Yeah, it's right here. Were you not here yesterday? I don't know how. Unless you weren't in here when I passed them out. But right there. If you didn't have the homework yesterday, you should have been like, wait a minute, I don't have the homework. So guys, for an example like 5 and 3, if you need to find the distance between 5 and 3, we can do 5 minus 3, and the distance is 2. But when we start involving positive and negative numbers, things get weird. So what your work should look like here, and you could have gone on to homework help to get some help, is absolute value bar. It doesn't matter what number we start with, but here's my Hudson advice. If you have a positive and a negative, start with your positive. So guys, if you haven't done this question yet, you should be doing it right now. I cannot believe it when I'm at home grading homework and I find a problem that's not done and I know we did it in class. Like, drives me crazy. Because then I got to give you a check minus and I know you're going to do it on your own. So we start with the positive. Then minus, because we know we got to subtract. And then in parentheses, our negative number. Negative 27.1. And then we close our parentheses and close our absolute value. What does minus a negative do? It adds minus a negative, and guys, you should draw this work, especially if you're not very comfortable with it. Minus a negative becomes plus a positive. So now we have 53.2 plus 27.1, still inside the absolute value bars. Yeah. And now here, my absolute value bars aren't even necessary, but if I had done this the other way around, the subtraction the other way around, I'd have negative 80.3 right now. But distance cannot be negative, so we take away the absolute value bars and make the inside of this positive. Well, it already is, so it just stays positive. Guys, I'm going to draw a picture to make a little bit more sense of this, okay? So stick with me. Stick with me. If we want to justify this with a picture, let's say I have my number line, and we have negative 27.1. I'm going to put my numbers up here. And you can draw a picture too if you want. It might help you. 0 is going to be somewhere around here. And up to 53.2. How far is it from negative 27.1 to get back to 0? Well, yeah, distance is always positive. So this is 27.1. How far is it if I need to go from 0 out to 53.2? It's 53.2. So if I need to make this entire journey, it's 80.3. B works exactly the same as A. You got a positive number and a negative number. C, give me your eyes. C's easy. Sorry, bad word. But check it. Think about your number line, right? If you have two negative numbers, so you got 0 in the middle, and we have two negative numbers, right? Two negative numbers. We'll call them A and B. It's the exact same as if you have two positive numbers, because the distance between here works the same as the distance between here because they're both going to turn out positive. So in C, you can actually act like they're positive. Since they're both negative, you can actually act like they're both positive if you want. That's your little trick there. I have no idea. I think it's going to be 20, 30, 30 something? 31.6, they tell us. So to check your answers, we have 80.3, 99.84, and 31.6. This is definitely one where we're going to need to have work shown. You cannot just have answers. So your work should look something like this. One number minus the other number, but we had minus a negative, so it turned into a plus. Any questions remaining on 8? We're going to check the rest of the homework, but any questions remaining on 8? See, I'm not going to give you guys the answer. Well, we'll check the answer. It's 31.6. Like, I'm not going to do it for you guys. The trick I told you was with negative 7.3 down to negative 38.9, it works the same as if we had positive 7.3 and positive 38.9, because the distance between the two negative numbers will work the same as the distance between the positives. So here's the two different ways to set it up with subtraction. If you need to copy this, you can, and of course I'm filming. You can always go back and pause the video. One number minus the other number. The tricky thing is they're both negative. So this is why I'm telling you we can treat it like they're both positive and do 38.9 minus 7.3. I know I said I wasn't going to do it for you, and now I'm doing it for you. And we can just do that subtraction. That will get us our answer. All right, back to the answer key. In 9, we got 110 songs, 84 pairs, and 5 miles. Any questions on any of those? Do you see your mistake now, though? In 10, we're looking at those pizzas. Trust me, I'm not a CPM author, but there's pizzas in CPM. Vanessa? Tito walked 3 more miles than Danielle. So I have a clean one to write on that looks like you guys. So if you have not done 9C, you should be pulling up 9C to do it with me right now. Hint, hint, nudge, nudge. Tito walked 3 miles more than, and I'm actually going to highlight Danielle in a different color. Danielle walked 2 miles. So how far did Tito walk? Tito walked. Tito did. Tito is, he had, was, whatever word you want to say, is equals. 3 more than Danielle. Well, that's Danielle plus 3. So Tito is Danielle's number plus 3. 3 more than. Sometimes more than means one of these symbols, right? Like the alligator. But that normally we say greater than when we're talking about that. More than tells us plus, right? More and. So then, since we know D is 2, we can replace our D with 2 and say Tito walked 5. Other questions?
Did you go to back to see if you got 3-23?
What? 23?
Oh.
Are you on the wrong homework?
That's on the next one.
Yeah. So make sure you're checking the right homework. Any questions on the back? Anyone need help on 311? It's like a puzzle. Be honest. Who needs help on 311? Come on. Yeah, come on, people. Ask me questions. That's my job. Guys, I don't care if you can copy down answers. I want to help you if you need help. Check it. 311. Look at it. If you haven't done it, 311. It's also a band I listen to. This is a puzzle. We know one related piece right now. The 100 came from a multiplication. I had people come to me who weren't even reading this problem. It's a multiplication down here. How can we multiply to make 100 when 5 is one of our numbers? Well, 5 times 20. So a 20 goes over here because those two numbers multiply to make the number inside the box. Likewise, this 200 came from two numbers that multiplied, so it has to be 10. Then, since we know the 10, we can fill in everything else. What is 10 times 7? And what is 5 times 7? Guys, this problem's not done until you get your final answer. So 200 and 100, I got 300, I got 70, I got 35. Any other questions from the homework? Yeah, Layla. Yeah, thank you. Guys, if I haven't said this yet this year, if we don't finish the textbook, it's fine. If we don't move as fast as we want, like, as I planned, it's fine. I'd rather take questions. So please ask questions. You said 10C?
Yeah.
As in, like, Charles. Julia wants to write the amount of leftover pizza. Ooh, leftover pizza. As a single fraction. Ooh. Now, this is where some of you actually made your jobs harder on the mastery, because I've started giving some feedback. You can leave fractions improper unless you get told that you have to convert to a mixed. So, A and B help us get to C. So essentially, I'm going to work through A and B to get down there. So what fraction of pizza is left in A? Well, 1, 2, 3, 4, 5, 6, 7 out of 12. In B, I might as well just go label each of these. B is 1/12. Are we sure it still has 12 slices? C is 5/12, I think. D, 2, is that still 12ths? And E, 10. So, actually, conveniently, we have common denominators, right? These pizzas must have all came from the same place. So a single fraction, not a mixed number. This means we're probably going to be improper. We might not be, but we're probably going to be. So we're going to add them all up. 7/12, 1/12, 5/12. That, not equals. What am I doing? 2/12. If you haven't done this and you're not writing it down right now, you're just crazy. Because you have to do it eventually. Denominator is common, stays common. Add up all the numerators. I think 25. That's it, you're done. Stop there. Like, that's a single fraction. If you make it 2 and 1/12, it's right, but that's not a single fraction. Right? This is a mixed number, not a single fraction. This is what we want as our answer. Questions? Don't do that. I mean, if you do this, it's right, but it's not what they asked for. Other questions? Going once. Going twice. Alright, you need out graph paper because we need to take notes, but keep out 312. Please keep out 312. It's got our first problem from class. But before we can attack this problem, we got to learn a little bit because we don't know something that's in this problem. So if you look at your 312, we got this, and we got this. We got little baby numbers. Little baby numbers. Man, you saying "we" just made me think of the little piggies, like nursery rhyme. Little piggy goes "wee wee wee" all the way home. All right, so we got to switch over to here. Oh yeah, math lunch. Math lunch is going to start to become a thing, especially as weather gets crappy. Unless I have a club happening at lunch, I'm going to be in here doing math with people that need to catch up. So if you are working ahead or working on current homework, you can come, but I'm not going to help you. I need to help people that need to catch up. Okay, so at lunch, we're going to be doing math to get people caught up. Some of us still have some catching up to do. We were going to talk about this whole playing with parentheses and moving numbers around. We'll probably do this another day because I'm running out of time today really quickly. So if you have any notes from yesterday about how many answers can we get, actually the afternoon class, I'll go ahead and tell you, we kind of got stuck on 11, and then we think we found a 12, but I don't know if we can make any other numbers than 11 and 12 off that problem from yesterday. But if you don't have that, that's okay. We're moving on to today. So on your graph paper, I want you to write on the word powers. Not superpowers.
Superpowers.
Math powers.
Not superpowers.
When we raise That was almost bad. When we raise a number to the second power, and you don't have to write all that down. When we raise a number to the second power, there's a better way to say that. There's a better way to say raising a number to a second power. And if I write this down, I bet you'll think of that way to say it. Because you're used to it if you've ever seen this, and some of you maybe haven't. When we write it like this, little baby 2, how else do we say that? Squared. So go ahead on your paper, write down like 3 to the little 2 or whatever you want. That's if we want to all do the same thing, that'd be the best. Guys, I'll admit, I love most of the teachers that I had growing up, but I think there were some things they didn't teach. Like, they taught me how to do the math, and my brain immediately said, okay, good, I know how to do it, move on. But I didn't know what was happening. So I'm trying really hard to make sure we know what is happening. 3 squared says take a 3. Right, like a unit of 3. And go ahead and draw this on your paper. And make a square with it. And if I make a square, I know it's 3 by 3. So I'm going to go ahead and slice up my 3 by 3. You are on graph paper, so this should be easy to do on your graph paper. If I make a big square, that is length of 3, width of 3, how many little squares do I have? 9. So mathematically, like what my teachers told us to do is just squaring is taking a number and multiplying it by itself. But the reason that is happening is literally you draw a line, however long you want, and then you make a square. And when we make that square, we have length and width that are equal, so like 5 squared. 5 by 5, and you don't have to draw this. How many little squares does it take to make a 5 squared? 25. And this, I will get up on my soapbox again. I should put a sign on this that says Mr. Hudson soapbox. If you guys don't know what that means, like when people complain or want to like people used to bring a soapbox to a town square and like stand on it and like yell things like the government is evil and like whatever. So it's just a figure of speech. The game 4 squared. Horribly named. Because 4 squared. And I know the game is called 4 square, but 4 squared, how many squares are in 4 squared? 16. Are there 16 squares in the 4 squared? No! So what should 4 square actually be called? 2 squared. You guys should go tell Mr. Smith, 4 square needs renamed. We need to call it 2 squared. No more 4 square, we gotta call it 2 squared. So, what if I make that baby number a 3? What if I make that baby number, do we have enough written down from this? Do we have any questions left from squaring? The little baby 2 tells us to square. Can you what? Make a petition. That's awesome. The little baby 3, so let's go ahead and write down like 3 with a little baby 3. We can call that the third power, or we need to know this to answer the first problem. Yeah, we need it. This is not a problem. I'm just teaching you. I'm like out of the book teaching you. Who would have thought? Guys, this means what it says. We cube the number. But this is way harder to like understand. So stick with me. I take a length. Don't draw this because it's kind of tricky to draw first. I take a length of 3 and I square it. So I made a square that is 3 by 3, but it's disappearing into the background. And then I grab the bottom and I pull it up to make it a cube. I did not draw this high enough up. So I am 3 by 3, so my base, how many squares are in my little base? 9. And then if I stack them 3 tall, what is 3 times 3 times 3? No, you do not have to, because I know it's kind of difficult, especially on graph paper. It's hard to do this on graph paper. I'm about to blow your mind, though. If you were to want to draw these things, no. I have special paper. If you guys are ever working on stuff. If you guys are ever working on things and you would like special paper, this is graph paper, but for drawing in 3 dimensions. So see the cube? So like here's the bottom of the cube. Right? And this is... and then you can draw like as big as... So it's all about shading. Or isometric dot paper. Right, we can draw our own cubes. It gets a little tricky though. Alright, so. Cubing. Hold up, let's make sure we understand this. What my old school teachers would have just said memorize is you take the number and you multiply it by itself, by itself. So there are 3 of them, right? So like 4 cubed, 4 times 4 times 4, get 64. But what is happening is we took a length of 4 and we made it into a cube. So 4 by 4 by 4, there will be 64 little cubes in there. Another example, Rubik's Cube. Right, if you take apart a Rubik's Cube, it's actually missing the very middle because it's got the mechanism. But this face, 3 by 3, 3 by 3, it's a 3 cubed. Right, a Rubik's Cube would be a 3 cube, well, depending on how big your Rubik's Cube is. All right, so now that we know this, we might be able to answer the first problem of our lesson. I do not need you to draw a diagram. If you want to, you can, but we don't have a lot of time today. What I do want you to do is, with your team, decide how many terms are in each of these, and then simplify it down. This is on your worksheet. This is the first problem on your worksheet. 312 homework. We're looking at 312. It's right here. Yes. What splits up terms? Addition splits up my terms, and subtraction is the same thing as addition. Right, so we have 2 additions here. How many terms? 3. 3 terms to start. 3 terms to start. Go ahead and keep working. Ooh, wait, hold on. I got a question. Does this split terms? No. Addition in the parentheses doesn't split terms. So my second problem here only has 2 terms. Our second problem here only has 2 terms. There's nothing to do with -3 at first. Should I do -4 times 2 or do the 2 cubed first? The 2 cubed needs to happen first. I need to say, well, what is this actually? Well, a 2 by 2 by 2. 2 times 2 is 4 times 2, 8. Guys, look up here, please. Your work should look a lot like this, directly under that problem. The -3 does nothing at first. The -4 does nothing at first. The only thing we really care about is figuring out what is 2 cubed. Because we know that's actually a different number, right? We can figure out how many things is 2 cubed. It's 8. Right? 2 cubed, 2 times 2 times 2 is 8. Now we can start putting numbers together. What do I do now?
Now multiply.
The multiplication. We don't know PEMDAS yet. We haven't learned that.
We haven't,
Well, I haven't taught it to you.
oh yeah.
I keep running into that with just my foot, so it's no longer going to be there. Guys, when we get our masteries back, and now that we're in a quarter 2, now we're going to have a separate progressing to mastery, and I'm going to write it specifically to what we're missing. I'm telling you, it will help if you team numbers up. Good guys with good guys, bad guys with bad guys. So positives with positives, negatives with negatives. -3 and -32, what do we get? -35. Team them up. Then they fight against the +5. Who wins?
The bad guys.
The bad guys by how much?
-30.
Give me your eyes. My room moves around a lot because I'm kind of like unfocused. But this board, I tried to write specifically for the Math 7 class with whatever we're doing right now. So here are your reminders if you're doing practice work and whatever else. An expression is what we're dealing with right now. It's a math statement with terms, right? Terms, words, right? What numbers, right? Things, variables, stuff. You can call terms stuff. It's an expression with stuff. But we separate it by and, right? So I say, I teach a Math 7 class and a Math 8 class and a Math 2 class, and splits things. So mathematically, and splits up. Every time we have an and, it splits a term from another term. So up here we got 3 terms, but then the goal is simplify it. Put them together. Now eventually we won't be able to put everything together. We'll end up with like some numbers and some letters, right? Variables. But right now, we want to simplify all the way down. Questions on like what we're doing. This is just an example that'll live here for probably the week at least. Here's the tricky part. This can have 2 different answers. Look up here. Unless you're working with Miss Martin. This can have 2 different answers. -3 squared versus -3 squared. What were we messing with yesterday that was changing how many answers we could have? Parentheses. So look up here. Keep watching. If I solve this like that, it's different than if I solve it like this. Watch. Just put your pencils down. This says the opposite of 3 squared, which 3 squared is, what's 3 times 3? 9. What's the opposite of 9? Well, -9. But if I come over here and say, what is -3 squared? Well, that's like times itself, right? What's -3 times a -3? What's a negative times a negative? If you don't remember, over there, multiply, divide, same signs, positive answer. This becomes +9. And guys, your calculator can get this wrong because it doesn't know what you mean. We have to use parentheses or we have to agree on what we're saying. Exactly. So really, I take issue. I'm mad at how they wrote this. Technically, the negative happens last. Because if everyone keeps yelling at me about PEMDAS, I don't know, PEMDAS is somewhere. I lost the PEMDAS poster. But PEMDAS says exponents happen before the negative in front. So we're going to take this route where we get negative 9 here.
That's what I did.
We're going to take this route where we get negative 9. So if that is negative 9 plus, sorry, I missed my 4. 4 times what? So guys, remember, the mom. Can anyone tell Katie what I'm talking about? Because since she wasn't here yesterday.
Oh.
Who can raise their hand and tell Katie what Lucas?
Parentheses are like your annoying little brother that always goes up to your parents like, Ma. And you're like, I'm like, what? Oh, I forgot.
And they demand that you take care of them first. Right? They're demanding your attention. So we got to do this first. What's negative 2 plus 5? 3. It's the first thing we take care of. It's annoying. Once we take care of it, we can move on. Then we get negative 9 plus 12, and that gives us a positive 3. We are obviously going to pick up this lesson again tomorrow, but you should still try to do your homework. But we are out of time for today. I know we're on that weird drill schedule, so classes are shorter. We will do more with this tomorrow, and I will definitely take homework questions.
So, on Wednesday,
I think I angled this wrong. I think it should be like that. We should have talked about what is 1 cubed. It's just 1. Right? 1 times 1 times 1. It's just 1.
it's cube of 1.
What's up?